The Foundations of Geometry by David Hilbert.
Chapter 5, Desargues' Theorem. Section 29, Construction of a Geometry of Space by aid of a Desarguesian number system. Suppose we have a Desarguesian number system D. Such a system makes possible the construction of a geometry of space in which axioms groups 1, 2, and 3 are all fulfilled. In order to show this, let us consider any system of three numbers x, y, z of the Desarguesian number system D as a point, and the ratio of four such numbers u, v, w, r, of which the first three are not zero, as a plane. However, the systems u, v, w, r and a, u, a, v, a, w, a, r, where a is any number of D different from zero, represents the same plane. The existence of the equation ux plus vy plus wz plus r equals 0 expresses the condition that the point xyz shall lie in the plane uvwr. Finally, we define a straight line by the aid of a system of two planes u prime, v prime, w prime, r prime, and u double prime, v double prime, w double prime, r double prime, where we impose the condition that it is impossible to find in D two numbers a prime, a double prime, different from zero, such that we have simultaneously the relations a prime, u prime equal to a double prime, u double prime, a prime, v prime equal to a double prime, v double prime, a prime, w prime equal to a double prime, w double prime. A point xyz is said to be situated upon this straight line u prime, v prime, w prime, r prime, comma, u double prime, v double prime, w double prime, r double prime, if it is common to the two planes u prime, v prime, w prime, r prime, and u double prime, v double prime, w double prime, r double prime. Two straight lines which contain the same points are not regarded as being distinct. By application of the laws 1 through 11 of section 13, which by hypothesis hold for the numbers of D, we obtain without difficulty the result that the geometry of space which we have just constructed satisfies all the axioms of groups 1 and 3. In order that the axioms, too, of order may also be valid, we adopt the following conventions. Let x sub 1, y sub 1, z sub 1, comma, x sub 2, y sub 2, z sub 2, comma, x sub 3, y sub 3, z sub 3, comma, be any 3 points of a straight line. U prime, v prime, w prime, r prime, comma, u double prime, v double prime, w double prime, r double prime. Then the point x sub 2, y sub 2, z sub 2 is said to lie between the other two, if we have fulfilled at least one of the 6 following double inequalities. X sub 1 is less than x sub 2 is less than x sub 3. X sub 1 is greater than x sub 2 is greater than x sub 3. Y sub 1 is less than y sub 2 is less than y sub 3. Y sub 1 is greater than y sub 2 is greater than y sub 3. Z sub 1 is less than z sub 2 is less than z sub 3. Z sub 1 is greater than z sub 2 is greater than z sub 3. If one of the two double inequalities exist, then we can easily conclude that either y sub 1 is equal to y sub 2 is equal to y sub 3, or one of the two double inequalities 2 exist, and consequently either z sub 1 equals to z sub 2 equals to z sub 3, or one of the double inequalities 3 must exist. In fact, the equations u prime x sub I plus v prime y sub I plus w prime z sub I plus r prime equal to 0, u double prime x sub I plus v double prime y sub I plus w double prime z sub I plus r double prime equal to 0 for I equals 1, 2, and 3. We may obtain, by a left-sided multiplication of these equations by numbers suitably chosen from D, and then adding the resulting equations, a system of equations of the form u triple prime x sub I plus v triple prime y sub I plus r triple prime equal to 0 for I equals 1, 2, and 3. In this system, the coefficients v triple prime is certainly different from 0, since otherwise the three numbers x sub 1, x sub 2, and x sub 3 would be mutually equal. From x sub 1 less than greater than x sub 2 less than greater than x sub 3, it follows that u triple prime x sub 1 less than equal greater than x triple prime u sub 2 less than equal greater than x triple prime u sub 3, and hence, as a consequence of 4, we have v triple prime y sub 1 plus r triple prime less than equal greater than v triple prime y sub 2 plus r triple prime less than equal to greater than v triple prime y sub 3 plus r triple prime, and therefore v triple prime y sub 1 less than equal to greater than v triple prime y sub 2 less than equal greater than v triple prime y sub 3. Since v triple prime is different from 0, we have y sub 1 less than equal to greater than y sub 2 less than equal to greater than y sub 3. In each of these double inequalities, we must take either the upper sign throughout, or the middle sign throughout, or the lower sign throughout. The preceding considerations show that in our geometry, the linear axioms 2, 1 through 4 of order are all valid. However, it remains yet to show that in this geometry, the plane axiom 2, 5 is also valid. For this purpose, let a plane UVWR and a straight line UVWR, U prime, V prime, W prime, R prime in this plane be given. Let us assume that all the points XYZ of the plane UVWR, for which we have the expression U prime X plus V prime Y plus W prime Z plus R prime greater than or less than 0, lie respectively upon the one side or upon the other side of the given straight line. We have then only to show that this convention is in accordance with the preceding statements. This, however, is easily done. We have thus shown that all of the axioms of groups 1, 2, and 3 are fulfilled in the geometry of space, which we have obtained in the above indicated manner from the Desarguesian number system D. Remember now that the theorem of Desargues is a consequence of the axioms of groups 1, 2, and 3. We see that the proposition just stated is exactly the converse of the results reached in section 28.
The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice: this ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Renholt. Programming and illustrations by Jim Renholt. 2019. Portrait of David Hilbert by Rita Ray Renholt. Thank you for listening.